This is tutorial question number 4. A 4-meter wide tank with curved surface AB as shown is used to store oil of specific gravity 0.72. The tank is vented to the atmosphere. Determine the resultant hydrostatic force acting on the curved surface AB. So let's say we have a tank like this one. So we have a curved surface here, but this curved surface is based on a circular, but it is not 90 degree. So if we have a 90 degree circular, so we could calculate it as a quarter circle, but because it is less than 90 degrees, so it will become a sector of a circle. So I hope you know to calculate the area or the volume for a sector circle. So here from the question, so the oil, the gasoline is until this level, but this tank is vent to the atmospheric. So the word vent to atmosphere here means, so it's still the atmospheric pressure can be act on the surface of this gasoline. So and then we assume the atmospheric pressure is equal to 0. So means that this is the free surface in this situation. So we could calculate the horizontal force. So again, we know that we are focusing on this sector circle. So and then we could draw the projection area like this one. So we have the projection area of this one. So and this is the centroid. So because this is the free surface, so the distance here is the HC. So I think you could calculate this one. So based on the diagram, we could know that the height of the projection area is 0.8. So and then this distance is 5.2 meter until the center of the circle. So and then we have another 5.2 meter above the center of the circle. So we could calculate the horizontal force using this equation, and the width is 4 meter here. So and then the horizontal force is equal to 244.1 kilonewton. So and then we could calculate the vertical force here. So using the equation of rho g volume. So this is the volume here, and 131.3 is the volume of this area. So you could calculate the area of the sector of circle here. So and then you plus with the triangular area here, and then you add with the rectangular here. So the total is 131.3, and then we could calculate the vertical force is 927.4, and the resultant force is 959 kilonewton.